Hello everyone. In today's video we're going to be looking at permutations. Permutations, that describes all the different arrangements you can make out of a group of things. So let's take a look here. In permutation, order matters. So let's say you had a coin and you flipped it twice, and the outcome you had first was heads and tails, or heads first, tails second, and then you got tails first, heads second. Those are two different permutations, so order matters. There's another arrangement called a combination where order doesn't matter, so those would both be the same combination, but here, talking about permutations, they are different. So let's look at an example real quick. It'll start to make sense the more you work with it. So here we have a dog, a cat, and a duck. First, we want to know how many different permutations are possible for the dog, the cat, and the duck. And to figure that out, we use the counting principle. And we multiply. But we have to make sure that we're multiplying by one less each time. The reason there is that you have, your maximum number of options for your first choice. So we have 3 options for our first choice. All right. Once you choose one of those, you have one less the amount of options for your second choice. So for the second choice, we only have 2 options. All right. And then for our final choice, we only have 1 option left. And that's how that would work out, no matter how many, items you're choosing from. So there are 6 possible permutations. All right. That's not too many, so we'll list them. So the obvious first permutation is a dog. I'm going to abbreviate. So DO for dog, a cat, and a duck. And we'll do DU for duck. So dog, cat, duck. All right. Well, we could also do the dog, the duck, then the cat. All right. That's a different permutation because we flipped the order of the duck and the cat. Okay. Now we could also do the cat, the dog, and the duck. Or we could do the cat, the duck, and then the dog. Finally, we could start with the duck. We could do the duck, the dog, and the cat. And the last permutation we could make, the duck, the cat, and the dog. So those are all the different unique permutations that can be made out of these 3 animals. All right, here's a couple more examples. How many permutations could be made out of all the students in my classroom? We have 11 students in my classroom. So if I was coming up with all the total different ways I could arrange all 11 students, say for my seating chart, how many permutations would that give me? All right, so for my first option, I've got 11 students to choose from. And for my second option, I've got 10. For my third, I have 9, and so on. And I keep multiplying in that fashion. All right. And when I do that, I get 39,916,800. That is a lot of options. That's all the possible ways I could arrange just 11 students in my classroom over 39 million arrangements, permutations. Okay, what if I just want to make pairs of students? So how many different permutations could I make out of pairs of students in my classroom? Here's how you do this. For a problem such as this, you're only going to multiply as many numbers as there are options. So for this problem, we're only going to multiply two numbers. So for my first student, I would have 11 options, and for my second student, I would have 10. I don't know why I put a comma there. It's not necessary. So I would have 11 times 10 to find the permutations of pairs. And this, of course, would come out to 110. So I've got 110 different permutations of pairs of students. All right, let's practice a few more here on the next slide. How many permutations can be made out of the numbers 1, 2, and 3? All right, obviously, I've got three choices for my first, two for my second, and one choice for my third number, and that comes out to 6 again. So let's list them. Well, the first one is obviously 1, 2, and 3, but I could also do 1, 3, and 2. All right, I could do 2, 1, and 3, or I could do 2, 3, and 1. I could do 3, 1, and 2, and finally I could do 3, 2, and 1. Makes sense, right? Okay. How many permutations can be made out of the letters T, U, and V taken two at a time? List them. So how many options do I have for my first letter? 3. How many options do I have for my second letter? 2. So that's all I work with, just the 3 and the 2, and I can get 6. All right. So what are those possibilities here? Well, first we have T and U. All right. Then we have T and V. All right. We have U and T, which remember is different than this permutation up here, and we have U and V. Finally, if we start with V, we have V and T, and we have V and U. All right. Okay, down here. How many permutations can be made out of a rectangle, a cat face, a clover, and this biohazard sign, or this whatever that is? All right, so how many permutations can we make? Well, how many choices do we have for our first shape? We have 4. How many for our second shape? We have 3. How many for our third shape? 2. And finally, 1 choice for our last shape. So we have 4 times 3 times 2 times 1, which is 24. Okay, I hope that my explanation of permutations made sense to you, and I hope that it helps.